Forget what I said before. This is the hardest question I've seen in a mathematics paper. Now, it's a standard question, but both advanced and standard can be asked this. My standard students have struggled with it this week, but the advanced students are doing okay. Let's give it a go. So Wilma is putting some money into a bank account. It earns 2% per annum. We want to find the minimum amount that she put in for the given annuity. So the first annuity is $1,000 for 20 years. We need to match up the 20-year period with the 2% interest rate to give us a present value factor of 16.351. So the present value of the first annuity is just going to equal the $1,000 that she puts in times by the present value factor, which is going to give us $16,351. That's the first part. That's easy. The second annuity is where it gets a bit confusing. So it's $3,000 for 10 years, but it starts in the year 21. So after this, the first annuity. So it's a 10-year annuity. Let's just go with that for now. Forget that it starts later on. So we're going to match up our period, which is going to be 10 years with 2%, giving us a present value factor of 8.983. So the present value here is the $3,000 payments times by the factor of 8.983. Okay, so this means the present value of the second annuity is $26,949. But this is where students get confused. It happens 21 years in the future, 20 years after. So the first annuity happens and then this. So if we drew it diagrammatically, the first annuity is the first 20 years down here. The second annuity, in this color, is going to be the next 20 years down here. So when we find the present value of the second annuity, we found it at what I call a temporary year zero. This temporary present value in year 20 needs to be brought back to the real year zero. We need to discount it. We need to find its present value again. We use the present value formula. So it's going to be the future value, which is now this present value. We're going to call that the future value, divided by 1 plus the interest rate of 2% to the power of the fact that it starts in 20 years. I know it's 21, but it's because the first payment's at the end of that 21st year. So discounting it back 20 years gives us a new present value of 18,135. All you need to do now is you add the 16,000, the present value of the first annuity, the present value of the second annuity, the 18,000, gives you a final present value of 34,000, it should come up on the screen in a second, 34,486.94. Oh, 90, done. Let me know if that made sense.